My name is Daniel. I'm the program director for Open Source with SLU, and our mission statement, our fancy mission statement, says that we support open science and sustainable innovation by delivering value for researchers with software and tools and providing students with realistic software development experience. And what does that all mean? The experiential learning is the realistic software development experience, and the software and tools that they generate as part of that is what we our outputs from that. And as part of that, we drive open science and open source. So I want to start with this story from Thich Nhat Hanh. He told a story of a gardener who planted lettuce, and the lettuce struggled and wilted. And our first instinct might be to look at a situation like that and say that this particular variety of lettuce is no good, or these seeds are bad. But he reminds us that there's a different set of questions that we should probably ask. What does the lettuce actually need to thrive? Does it need better soil? Does it need different light? Does it need perhaps more nutrients? So what he's basically prompting us to do is have a shift in our perspective. When something isn't flourishing, don't just look at the thing, look at the conditions of the thing. And so today I want to share with you how we stopped trying to fix students and started to amend our soil. Ha ha ha. Okay. So prior to having this program, we had a very traditional computer science capstone, and we had pain points associated with that. Students were treated as student developers, and there were academic exercises with limited real-world impact. The mentorship opportunities that were involved were limited to instructor oversight. There were common code quality issues that we would see over and over again. There were significant sustainability challenges around the projects that we would see over and over again, where even the most promising projects often would just go and sit on a shelf. It was a competitive environment rather than a professional collaboration environment. And obviously, professional dynamics can vary, but we were not necessarily bringing out the best in people. And there was limited real user interaction and validation with the work. And just in general, the model that we used to support our computer science capstone was a one-on-one mentorship relationship with faculty that had significant scaling challenges as our student cohorts were growing larger and larger. So we started asking questions. We started wondering, how do we deliver these authentic professional development experiences? How can we develop professional skills and avoid academic nerd snipes? How do we work in real code bases and provide meaningful technical mentorship? How can we help students deliver real value in the world? How can we ensure that what we deliver has real long-term impact? And how do we do all of this at a growing scale with relatively limited means? So our solution is really treating students as professionals and giving them layered support. And what does that look like? So the program itself, we input computer science students with significant academic training. Possibly they've got prior experience, potentially through internships or through other mechanisms. We enroll them in a computer science capstone course. This is supposed to be a summary academic experience. And then we hire them as contingent workers so that it becomes not just an academic experience, but a professional experience. We give them a structured process with sane defaults to ensure a smooth onboarding. We provide multiple tiers of mentorship, including industry fellows, tech leads, developers around them. We give real clients with genuine needs and authentic requirements and validation. We give them professional tools and processes that are based in software engineering best practices. We put them into an open source ecosystem where there's sustainable value and genuine collaboration. We drive towards real products with a long-term vision that involves design and implementation and impact. And we do holistic evaluations that involve a comprehensive performance matching the norms that are common in the professional world. And the result, hopefully, is a legitimate professional experience while delivering actual value as a student. And what the program looks like at a very high level, this is the overview of the entire program. That's our current architecture. And you might look at that and go, wow, there's a lot going on. I thought we were just talking about the capstone course. What the heck is going on here? Well, if we want to understand how we got to this point, it's important that we take a step back and understand the conditions under which it emerged. So to borrow the great quote from Carl Sagan, if you want to make an apple pie from scratch, you must first invent the universe. So how did we get to this glorious dawn? How did we bake an apple pie from scratch? Well, we started with a traditional capstone, and then we had an idea of how we could improve it. We grew that idea by introducing this notion of a tech lead. A tech lead is a very common pattern in professional software development teams, where there's some sort of senior person on the team who can act as a guide and a near-peer mentor with other people on the team. And when we started, we added this idea of clients, and we had the idea that we were going to be producing products, open source products, and that the open source program office, Open Source with SLU, would be the steward of those products, and the products would somehow magically deliver value to our clients. The tech leads we hired as graduate research assistants, and they were primarily responsible for the code base, maintaining the code base, ensuring quality in the code base, and sort of helping to navigate team dynamics. They weren't managers, but they were sort of ensuring that the team had smooth collaboration. That was great. The tech leads were integrating as near-peer mentors, and they definitely improved quality. The product mindset was very helpful. It connected built solutions to client needs. But we definitely saw opportunities immediately as we implemented this solution. The capstone students were still disconnected from ownership of the product. There was minimal engagement with the wider open source ecosystem, and there were significant sustainability challenges still around capturing sponsored work. How do we get paid to do some of this work? How do we capture grant funded work and integrate that into our process? And then we started to see hints of scaling challenges, and I'll come back to this. So we started evolving our program immediately, right? We started tinkering at the edges and playing with how the different pieces fit together. And we started introducing the idea of, oh, we want to hire people to do work, and they can't do the same work that they're getting course credit for, but we want to pay them to do additional work on top of that. So we hired people as full student workers. They could work up to 20 hours a week on projects as a student worker, and we would hire either graduate students or undergraduates, depending on the funding that was available in any given project. And that was great. We also started pushing the whole team to own the product. We shifted from the tech lead being the primary point of contact for the client to sort of encouraging everyone to directly engage with the client and own the product as a team. And the tech lead was just sort of there as a baseline to establish the minimum communication with the client that was necessary. We started making mindful efforts towards community engagement. We started thinking about how we could integrate community involvement into our products, but it was still sort of at the periphery. It wasn't, open source was just this sort of layer on top of what is essentially an agile software development process, which is fine, but not necessarily ideal. And we started identifying additional partners within the university that could provide additional infrastructure, both in terms of soft infrastructure and in terms of like meaningful opportunities to extend our reach in various ways. We still saw challenges though, even with this, as we rolled this out, we saw that the ability to identify research assistants was challenged. We were working primarily with professional master's students, people who weren't necessarily getting research assistantships. We weren't dealing with PhD students. They were already snatched up and associated with a particular PhD advisor. And so finding people who were qualified to do the work was a significant challenge. And we started seeing missed funding opportunities because we would have requests for small pieces of work here or there. Can you just do like 8 weeks of work or something like that? No, we have to hire somebody for a full semester. Oh, well, maybe it's not a good fit. Okay, let's move on. So, what did we do? We evolved. What else can you do? We started evolving again and we shifted some of the pieces around. This was when we got another round of funding and we totally restructured the entire program. Instead of graduate assistantships, we decided that we were going to have a separate co-located graduate course called Developing Open Source Software Products. And the graduate students that were going to be the tech leads would be enrolled in this course. The courses would be co-scheduled so that they would line up and we would have guaranteed meeting times when everyone was ensured to be able to meet because it was baked into their academic schedule. But immediately in designing that, we realized that there was an additional challenge that we had to address immediately. When we had research assistants, they would get prepared over the summer. They were on a long enough contract that they had time ahead of the semester start. They could be ready at the start of the semester to be a true technical lead. They could have a deep understanding of the code base that they were going to work with. They could start doing some of the planning work that would be required to get going immediately. One of the challenges that we face with an academic time schedule is even with 16 weeks, actually ends up being a very tight crunch, and we'll come back to that overall. We gave tech leads a specific responsibility. They were responsible for ensuring the long-term product vision. The client became a proxy for a wider user community in the open source world. And the tech lead's role was partially to translate the client's particular needs at a point in time into a wider set of open source product satisfying needs that would satisfy a wider user community. And that created an interesting dynamic. We'll come back to that as well. But one of the things that they ended up needing to output was two key documents, a community strategy and a product strategy. All right, so here we are building solutions that drive our products and actually engaging with wider communities. It was great. We had some gravitational binding going on. That was the grad course replaced the assistantships. That worked out pretty well. The BOLT workshop, the Building Open Leadership Toolset workshop that we ran ahead of time in the first summer leading up to this was a great success, and everybody was onboarded, ready to go on the first day of class. The product vision was being maintained by the tech leads, and they became responsible for handing off that vision from one tech lead to another. We had increasing professionalization. We started to introduce the idea of we're not actually students, we're developers. We're not graduate tech leads, we're tech leads. And that professionalization turned out to be very valuable and something that we leaned into in the long run. And we really started driving towards open source communities as a primary driver for how we work and what motivates the work that we do, not just our internal clients. We still saw challenges though, right? There's still opportunities to grow and opportunities to enhance the program in this really tremendous improvement to what we had done so far. Tech lead were increasingly asked to do more and more, and we were increasingly giving them less and less support, less and less one-on-one mentorship from open source with SLU staff and computer science faculty, and less just sort of time on their plate to do all the things that they needed to do. And we were still missing funding opportunities, right? We still were in this model where we were hiring people on a long-term basis, and we had short-term opportunities that we couldn't necessarily engage with. So the other thing that we realized is that community is not something that just happens overnight. We can have an intention of community, we can design around servicing the wider community, but even with that best of intentions, we're not necessarily going to have a community of users immediately. It's it's it just takes time for communities to emerge around anything that you introduce, right? Um, and we're still doing what is essentially single vendor open source, which is widely considered a less than ideal practice, less ideal than community driven open source product development. Um, and we were increasingly aware that we were dependent not just on our initial seed grant, but on grants in general. And we talked about trying to diversify the revenue sources for the open source program office, but this dependency on research grants and being able to be written into other people's research grants became increasingly obvious as a potential strain in the long term. So we evolved again. We evolved into metal-rich stars. If you've never seen a metal-rich star, I encourage you to look into the night sky and look for some metal-rich stars. Um, they're really good. You'll enjoy them. All right. So with the heavy elements that we introduced, we had an enriched composition. We added industry fellows. This was basically an opportunity, an invitation to people in the regional community to come and show up. And we asked them two things: be online in our Slack workspace and show up for 2 events per semester. Any interaction that you want beyond that is entirely up to you. You can make contributions to projects. You can get involved directly with any individual teams that you want to. But the minimum that we ask for everybody is just sort of be around. And the goal for us is really to provide an additional layer of mentorship and support. We switched to a contingent worker model where we basically hire everyone immediately, including the industry fellows, which is a nice thing. They actually become a university employee, and one of the perks that they get is not just the joy of working with young professionals and students. They actually get a few soft perks, like having a university email gets you access to the library, and having a university library access is actually pretty cool for some people. Or we have some co-working spaces, so they have access to a co-working space. We have just a few sort of soft perks that we're not paying them anything. They're still essentially volunteers, but they also get a background check, which is important for anybody working with students as well. And every student that we work with now is legitimately hired as a worker under this program. So it's legitimately not just we tell you it's on your resume, treat this like professional development experience. It is professional development experience. What that means, though, and I'll come back to what that looks like, is basically they're available to work and we can put them on small assignments. Very exciting innovation for us. We introduced more connecting events. This really started with the required events for industry fellows, but we're actually planning additional intentional community building events that are beyond just sort of the outreach events that we've already done on campus around driving open source, but intentional community building around open source with our people as the community, the core community members driving those events. We've got over time clarity over project product differentiation. What is a project? GitHub calls things a project. A project is maybe short-term. Are the things that we're building short-term? Our teams are certainly short-term, but our goal is to build long-term products. So, we're calling them projects in GitHub, and what does that mean? We've become much more intentional and clear about what that looks like. And this year, we've actually diversified the kinds of products that the kinds of projects that we were taking on and the kinds of products that we're developing. So in addition to the original client-driven products that we started with, we've added teams that do internal services. So we've got a CI/CD team, an infrastructure team, a metrics team. A cybersecurity team. And this is really driven by student interest. The students in the CS program are looking for a career in technology, but they're not necessarily looking at product development careers. So how can we service their needs? And how can we provide better internal services for all the things that software development actually needs? We have our very first entrepreneurship-driven product. It's a really fun robot kit. Very excited about the Smart Robot Kit. And we have someone who has expressed interest in the subsequent semester in doing a research-driven project where they have a faculty mentor in computer science and just do computer science research as their capstone project. And the structures remain the same, but some of the focuses shift slightly. So we've been able to diversify the kinds of things that students want to do and actually meet student needs better. One additional thing that we've done, this is unrelated to the capstone, but for the developing open source software products class, we've actually also started adding community-driven products. So rather than having any client-driven products, we have a few graduate students who are building their own team and building their own product vision that is entirely community-centered. It's not based on entrepreneurship. It's based on meeting, scratching an itch, so to speak, or driving some sort of value in the wider community. And we're at a point now where we feel like we've learned a lot and we're ready to start sharing our knowledge. We want this program to be reproducible in other contexts. There are elements that we know are specific to our context, but there are things that we would love to be able to see the wider community adopt. And we're starting to go beyond our single vendor products towards community first products. One fun thing that we're starting to poke at, we tried some experiments this summer with the building open source, what was it? What do we call it? The BOSS program. It's the BOSS program. Towards sort of driving universal participation, we've got campuses on Africa and we want to build skills in the wider university community. So we've been working with those students as well. And I mentioned that the connecting events that we're building, we're doing intentional community building. Those efforts are increasingly student-led outreach efforts. So Hacktoberfest used to be something that we would drive around on campus and do various things to push Hacktoberfest on campus, and now students are doing that. Girls Who Code and the student ACM chapter are driving the Optimal Snack Solutions Fund, which drives snack options in our co-working space and things like that. They're also going to be driving innovation challenges for us. So there's more things coming, but I could talk about it for hours, but I should probably move on. So what is the recipe? How did we actually build this thing? What are the ingredients and processes involved in building this pie, this cosmic pie? Well, let's talk about the work. We're talking about two different concepts. We've got increasingly clarity, like I said, about what we mean by product versus project. The product is a long-term vision. It needs to meet student interests. It needs to build wider enthusiasm. It needs to meet student abilities and build their professional capacity. It needs to meet our client needs, but it needs to build for a wider community. So keeping these tensions in mind about what we're trying to achieve and what we're trying to build to get to those things has been incredibly helpful in terms of understanding and identifying what we mean by product. And then projects are the short-term things. And there's still some ambiguity because GitHub still calls things projects. Our code bases are still in projects. And we have, anyway. But the short-term iterations that we work in, semester by semester iterations, balance client and code needs. Right? There's 16 weeks of focused work with 2 weeks of prep ahead of that. There's 2 weeks of onboarding to lead up to sustained activity, and about 6 sprints of 2-week sprints. So if you're familiar with agile software development processes, it's sort of we're following internally what essentially looks like agile software development processes. And then at the end, we make sure we have a launch. We ship something notable, and we celebrate that we shipped something. Who does this, right? So the client, I like to say, is perhaps the most important member of the team. They are a member of the team. They may never write a single line of code, but they are the proxy for the wider community. They drive the immediate requirements, and they are perhaps in that way then the most important member of the team. The tech lead is a near-peer mentor for a cohort of developers, and we provide additional supports through our industry fellows program, through the computer science faculty, through our various university partners, and through the open source with SLU staff. The teams themselves, we do team formation through a process called BLADE. which is a fun acronym, and it's sort of modeled on a knife fight or it's intended actually to sort of model a career fair. And essentially, every tech lead, having gone through a preparatory workshop ahead of time, knows the product that they're going to work on and gives a short 1 minute presentation. And then they have a predetermined team sizing in terms of a minimal team size. Some teams have a minimal, every team has a minimal team size of 2 developers because we have to do collaborative work. And there are maximum team sizes, and we've set the maximum at this point for 4 developers per team. And the team sizing is really done on a project by project basis. So during the Blade process, it's a first day of class. The first thing we do, everybody shows up, hears these pitches, and then goes table to table where the various tech leads are and essentially interviews for a job and either tries to find a good match for their interests and skills, or the tech lead is perhaps filtering people based on, if they've got lots of popularity, what are they going to prioritize that's important for them to have on their team. And then we really drive towards collaboration. If you think of open source norms of a contribution guide, we drive that home internally and sort of say that the contribution guide is something that you can dictate externally, but internally we have a team working agreement that is determined by the team as a whole. It's a negotiated document that the team maintains. So again, a standard agile process. We have a minimum of 1 weekly meeting that's synchronous. That is the class sessions on Mondays. And then we have a continuous virtual meeting through Slack and whatever additional cadences the team themselves figure out. And we have various co-working spaces available on campus, including spaces where they can store specialized equipment, spaces where they can have shared displays, and we're working on building out opportunities for them to do pair programming and beyond just the mob programming that's currently possible. Let's see. We use a professional development framework where language matters. We use real job titles because we want people to feel like this is a professional development experience. And we use the contingent employment model to make sure that everyone is actually employed. And we maintain professional communication standards. That doesn't mean stodgy, it just means professional. And we help students navigate that dynamic. We have a random channel in our Slack, and it is populated with cartoons and all sorts of fun stuff, but we make sure that we are consistent in our communication and professional in our demeanor overall. We use industry standard tools like GitHub-based workflows, Slack. We have standardized IDE recommendations, documentation norms. Essentially, we're running an internal software development bureau. So the norms that you might have for any sort of corporate software development are sort of de rigueur for us. But one thing that we really drive home is that team ownership is vital because we have such varied elements across the board. The most varied elements really require team ownership for decision making. I'm not going to tell the VR team that they have to be on site if they've already got their own VR equipment and they're working from home, right? That's a team decision that they get to determine on their own. All right. The tools we use GitHub Enterprise. We have sort of standard practices around that, like each project has at least one repository. We protect the main branch. We require pull requests, and pull requests must get a review by a tech lead. We use issues. We have project boards within GitHub. And we have standards around branch naming, commit messages, things like that. We drive towards continuous delivery. We recognize that that is a discipline, and every product will be at various stages of maturity with that. But we drive towards it, and we have standards around documentation that we push. Slack is our dedicated workspace for everyone. Our clients are all invited to use Slack as much as they feel comfortable. And we have product-specific channels for each team. The product-specific channels are all public to drive engagement with wider open source users and contributors. And they're long-lived to make sure that one generation of developers can pass along information to another, that they can support each other in that way as well. And we have a dedicated set of industry fellows channels, both public and private, that allow us to share information, allow them to be a resource for everyone, even if they haven't dropped into a particular channel. And we have course-specific private channels that allow us to sort of maintain communication with students in ongoing ways outside of traditional course-based communication mechanisms. I make sure to do weekly announcements. That's sort of part of the professional communication norms, sort of big weekly, here's what's going on in the world around you sort of announcements. And then we have various information and support channels in Slack as well. The local environments are tremendously varied. We tend to see VS Code as a very common thing. GitHub command line or desktop is very common, and Docker is very common. One of the things we really drive with our local environments is that it's very easy, especially when you're doing research software development, to have very interesting external dependencies, whether it's hardware or a particular environment. And so we try to build software engineering strategies around mitigating those. We have a new infrastructure team I mentioned. They're building some interesting stuff to support our internal development efforts as well. But because of the diverse development efforts that we have, anywhere from hardware IoT stuff to desktop-based stuff to high-performance computing environments to cloud-native environments and on and on and on, it's an incredibly diverse thing, and teams drive their own decisions, and we just sort of try to help shape and guide what makes sense in general. Like I said, regular async communication via Slack. We have those weekly synchronous meetings in person in class, and every 4 weeks we ask teams to do retrospectives. Again, the standard agile processes in many ways. The client communication is largely dictated by the clients, but one of the things that I ask is that if your client is not communicating with you at least once every 2 weeks, then there's some challenges that we need to work through, and we need to make sure that the client understands that we have we need them to validate the work on a regular basis, or it's not going to be a successful relationship in the long run. And developers are required to deliver demo videos at this point. Every piece of work that they deliver must include a demo video. That's valuable for both validation and also for general promotion. So interested in using that in the long term in terms of building the sort of product brand, product understanding, building the wider community. And we have escalation procedures in case anything goes sideways. And throughout the semester, I make sure to have multiple one-on-one opportunities with every student involved. Documentation, we've got some norms around. We've got minimums and preferreds, and mature products have dedicated documentation sources. We track all of our issues in GitHub, and this is an ongoing communication issue with students as they transition from understanding things as being a student to being a professional. But Slack is ephemeral, but the GitHub issue and the pull request comments ends up being a more permanent record of the work and the discussion around the work itself. And then we have various checkpoint documents, and I'll come back to those in a moment. And handoff documents for iteration transitions. The checkpoints build up towards handoff documents that are valuable. In class, we run various workshops around professional development and specific technical capabilities, especially in the graduate course. We do a lot of that in the graduate course and then hope that it percolates to the teams through the graduate student as a tech lead. The graduate students have additional readings as well that sort of drive their conversation and understanding about the work. We really have 4 themes in our readings. Developing sort of covers team dynamics. The open source, we cover the technical, ethical, social, legal dimensions of open source. Software, we cover software engineering fundamentals and drive home, how do you do software engineering well? And then products, we talk about product and project management as both skills and sets of ideas that you're building a vision and building a long-term and using your imagination, something that sometimes technical people are good at and sometimes they struggle to recognize their abilities in. And then I make sure to put a 10% stretch in everything that they do. For the undergraduate students, the developers, that 10% stretch is just sort of any demonstrations of excellence that helps us get outside of everyone doing the bare minimum and drives towards the bigger long-term vision of something that is things people want to use. And then for the graduate students, they have to make some sort of public demonstration of professional leadership. And that can vary from technical contributions to open source, big open source projects in the wider world, to giving a presentation at a local meetup or giving a paper at a conference or anything in between. So this is our process at a very high level. Our process is a little longer than 16 weeks, actually. We've got pre-iteration planning in our Building Open Leadership Toolsets workshop. And then once the semester starts, we really see the Tuckman model unfold of forming, storming, norming, and performing over the course of an entire semester. It takes us a little while to get to team formation just because of the schedules that we have that tends to be on the second week of class. But classes, yeah, long story. But it takes a little while for teams to onboard, and then we kick them off on sprint one, and then sprint 1 through 6 tend to be normal. We recognize that students have other obligations along the way, and we try to encourage tech leads to size work appropriately so that it matches the workload expectations for the kind of credit hours that they're enrolled in. The last sprint, we make a little longer to make sure that people can wrap things up. It also tends to overlap with some sort of holiday of one sort or another. So we make that a little longer, and then we make sure the final exam is not a final exam. It's actually our launch party. So we try to ship and celebrate by the final. And on a week-to-week basis, I'd like to tell them they go through a rhythm. They go through a dance. They do a discovery. They do delivery, and then the tech lead has to make a decision. So it's our 3D process right there for you in 3D. It's a very standard agile software development process in many regards. And so I don't want to go too far into that. But the goal here is to give them the professional skills that they need to be successful. And I think you might ask, well, how does agile software development map to open source? How is this relevant to open source? It's a very good question. I think for me, one thing that I've seen in the wider open source world is that the norms that people set for open source projects are often determined by their experiences as professional software developers. That's not universally true, but it's pretty common that people sort of set baseline norms based on how things have worked for them in the past when they've done it in other contexts. So they've adapted and accepted methods into an open source context, and that's fantastic. So we're basically trying to lay that scaffolding of skills, those professional skills that will enable students to engage with wider open source ecosystems successfully by building those professional development skills that are vital for any software developer. How do we assess all this? How do we evaluate the results? The assessment is done on a holistic basis. I'm looking at final outcomes. I'm looking at their overall growth trajectory. It's driven by evidence. We'll come back to this. And the goal is to give them strategic guidance for their career. All of the assignments, all of the deadlines, all of the points that are associated with the course as a course do not get calculated into a final grade. They are the evidence-based grounding for understanding what happened at various points throughout 16 plus weeks of work. Their indirect influences on the holistic assessment. The team itself gives feedback about everyone else on the team, including the client, and the client's voice ends up being a little louder in the overall assessment, but the team feedback is incredibly valuable as additional evidence as part of the holistic assessment. And then just sort of observational patterns that we see in terms of the communication and collaboration that unfolds. How are they actually doing that work? Collaboration ends up being a vital part of their overall holistic assessment. And so something that we take very serious is how well are they collaborating? And then at the end of the day, what have they delivered? Have they actually delivered the things that they need to on a week-to-week basis? Have they delivered the videos, the merged pull requests, the checkpoint documents, all these things? Those are important in telling us, are they staying on task and driving towards outcomes? The checkpoint documents are really about maintenance and hygiene. There are two kinds of checkpoint documents that we introduce. Some of them are sort of team or project-based maintenance, and those are things that the entire team ends up being responsible for. And some of them are product maintenance, and those are things that the tech lead ends up being responsible for. They're stewards of the overall product vision, and so they end up being responsible for maintaining the documents that track the health of the product over time. And one of the things that I like to talk about with the developers and the tech leads involved with this is the value of plans versus the value of planning. And in my mind, the documents themselves, once they've been handed off and read, they have limited value. They document our understanding of reality at a point in time and our conception of where we need to go in the future at that point in time. But the activity of doing the work of generating the document is in and of itself incredibly valuable. It's how we learn about what needs to happen or what is currently happening. And all of those documents get accumulated into a packet that can be handed off to the next tech lead, because we recognize that students graduate. We want them to do that. We want them to move on. But we need the product to have some sort of through line of sustainability. And so those packets end up being incredibly valuable. Those documents end up being incredibly valuable. And they don't have to have an hour-long meeting with someone. They can just hand them a document. Hopefully they're willing to do that as well. We want them to be engaged in the wider community in the long term. The 10% stretch is really important too. Again, it drives towards overall polish. We're looking for some demonstration of professional excellence, some demonstration of professional leadership, engagement with the wider open source community, and just sort of like make it cool, man, make it cool. So, all right. So what do we get? We get a universe of results. The outcomes, outputs, and opportunities that we get to taste that wonderful pie. It's amazing. We've been wanting this pie for 45 minutes now, I think, right? We've been talking about this cosmic pie. Let's dive in. What it looks like on the ground is sometimes chaos. Sometimes it's a lot of additional work that the students feel like it's a totally different experience than an academic experience. But we're really trying to, again, lay that foundation. There's a lot of collaboration both within the teams and with the industry fellows. And the goal at the end is for them to be able to be effective communicators about the work that they did, not just do the work, but be able to express what they did in meaningful ways. That's essential for community building as well. What that gets us as a program is really a three-legged stool. We're able to drive towards open science through open source, open science enabling sustainable innovation. We do that by developing research software that delivers value for researchers across the university, across the entire research ecosystem. And we have a workforce development program that drives experiential learning, right? So this three-legged stool is incredibly valuable in terms of proving our value within the institution and within both at the grassroots level, faculty understanding our value, students understanding our value, and at the administrative level. And we've done some cool things. We've built mobile apps, we've built desktop apps, we've built IoT systems, we've done data processing, we've done things with natural language and computer vision, and we've got emerging projects in VR, in robotics. We've got some really fun AI security tools that we're building, I'm very excited about, and some fun stuff, new stuff with computer vision and 3D analysis of various things. And over 3+ years, we've currently got 21 active products. Actually, that's not correct. We currently have 23 active products. That's an outdated slide. And we estimate that the value of development work that we've done is over $500,000 worth of development work. And at least 80 professionals. Currently we have 60 undergraduate students enrolled, 62, and 24 graduate students enrolled. So that's just current semester. Over 3 years of this, and they go through a full year of iterations of work on a product. They can join in either the spring or the fall. But we've actually done well more than that. I think it's a very conservative estimate. And that multiple semester handoff has turned out to be incredibly successful. We've been able to do that reasonably well. We've gotten better over time, I would say, as we've learned how to do it well. And so it's been really amazing to see how this has grown. And if anybody has questions, I have office hours every third Friday from 1 to 5 on Zoom. Would love to chat more in depth with anyone who's interested about the details of what we've done.